So we've talked about the least units of measurements, the lower limit, upper limit, and also the absolute error. Now we have another type of error which is the relative error. So when we're calculating relative error, the thing we have to know the formula. So relative error, I'll write it as RE, will be equal to the modulus, which is recorded value minus the true measurement over the true measurement. Now, we know recorded value minus true value in the modulus bars is the formula for absolute error. So relative error is simply your absolute error over your true measurements. That is the formula for relative error. So let me give you an example. So remember that piece of wood which I said was 6.5 centimeters long. And now if they tell us to find the relative error of that same piece of wood, so we said that relative error is equal to absolute error over the true value. Now, our absolute error, which we found in the previous question, was 0.05 centimeters. And now, to find the relative error, this would be simply 0.05 centimeters over the true measurement. So therefore, the true measurement of this will be 6.5 centimeters. Now, when we are finding this, so we just divide the true measurement into the absolute error. So now when we're dividing this, we know centimeter and centimeter would cancel. And then we would multiply this part by 100 because it has 0.05. Actually, no, we don't multiply the top part by 100. We multiply the bottom part by 10, then also the top part by 10. And then this would be 0.5 over 65. And then if we find that measurement, it would give us a digit which will be 1 over 130. So if you divide this on your calculator, it would give you 0.07692 going on. So that is how we find our relative error. So relative error is just the absolute error over the true value which you have been given. Now, what if we are told to find the relative error of that first question I gave you, where it said a table measured 48.7 centimeters, and then we have the true measurement as 50 centimeters. Then they tell us to find the relative error. So if you remember the formula, it would be the recorded value 48.7 in the modulus bars minus 50 over the true measurement, which is, so the true measurement, it said that if its true measurement is 50, so the true measurement which we would put down is 50, not 48.7, because I said if a learner measures the length of the table 48 and if its true measurement is 50, so the true measurement will be 50. So now we're going to say, would say 48.7 minus 50 in the modulus bars, which would give us a positive 1.3 over 50. And then if we multiply those two, it would give us, sorry, I meant if we divide those two, it would give us 0.026 as our relative error. So remember, relative error never has measurements because both the measurements on the top and the bottom would cancel each other out. Now we go to the percentage error. So percentage error is just equal to the relative error times 100. So we know relative error is absolute error over the true value. So absolute error of a true value by 100. That's how you find percentage error. So let's have another example so we can understand what I mean. So let's find the percentage error of a bottle whose measurement is taken to be 15.2 centimeters when its true diameter is 15 centimeters. Now that I've told us to find the percentage error of this bottle. So it has said the bottle's measurement is taken to be 15.2 centimeters and its true diameter is 15 centimeters. So what we do to find the percentage, we're going to introduce the modulus bus because we have two measurements, and then we're going to say our recorded value minus our true value over the true value, which is 15. Then would say this times 100. So now when we solve this question, it would give us, so 15.2 minus 15 will be 0.2, and then over 15 times 100. So the modulus of 0.2 is simply just 0.2. So we're going to say 0.2 divided by 15 times 100. And now 0.2 divided by 15 would give us 0.133. So I'll put this line, which means the 3 and the 3's, they go on, they continue until it goes on. So times 100, which will give us 1.33%. So that is our percentage error. So let's have a quick recap with this question with us today. So a ball has a diameter of 5.0 centimeters, and then A has told us to find the least unit of measurements, and also B, upper limit, the lower limit, and the absolute error. So according to what we've learned today, we're going to try solving this question. So you can simply just pause the video, try solving this question by yourself, and then we go through together after you're done and see if you have understood what you've learned today. So let's get to this question and then we try to answer it. So we had 15.02 centimeters. Then they have asked us to find the least unit of measurements of this value. So since we said it has two decimal places, so our least unit of measurement will be 0.01 centimeters, because 1 2, even here 1 2. So that is our least unit of measurements. So let's go to the second question. So now the second question is asking for the upper limit. So the upper limit is supposed to be our true value, which is 5.02, plus our least unit of measurements, which was 0.01 centimeters. So when we add these two, it would give us 5.03 centimeters. So that is our upper limit. And now the second question is similar. So the second question will be the lower limit. So the lower limit will just be the true value minus the least units of measurement, which would give us 15.01 centimeters as our lower limit. So if you got that question correct, you are doing really great. So if you didn't understand, just make sure you just watch the part on this video for the least unit of measurements, upper limit and lower limit, so you can understand the concept and make sure you practice more questions so you can get the hang of it. Now the next question is the absolute error. So the absolute error, we said it to be the least units of measurements. So our least units of measurements was 0.01 centimeters. Divide by 2. So since we only had one single measurement, we use this method. So it will be 0.01 centimeters divided by 2, which would give us 0.005. So 0.005 centimeters. That is the absolute error of the diameter of that ball. So now, another question. For the same ball of a 5.02 centimeters diameter, now we find the relative error and the percentage error. So you can pause the video, try answering this question, see if you can get the hang of it, or you don't need to pause the video, we can go through together and then we see how we're going to answer it together. So to find the relative error, it would be our absolute error over the true measurement. So our absolute error was 0.005 centimeters over the true measurement was given to us as 5.02 centimeters. So the 2 centimeters cancel, and then 0.005 divided by 5.02 will be 0.0000996. I've rounded off this. So that is our relative error. So now let's find the last one, the percentage error. So the percentage error is just simply our relative error times 100. So we found 0.0000996. This value has been rounded off, and then we just multiply that by 100. So if we multiply that by 100, our percentage will be 0.0000996%. Oh, sorry, no, that would not be, it would be 0.0996%. Not that, because we have we're multiplying by 100, so our decimal would move 2 times, giving us 0.0996%. So when you're finding the least units of measurement, it determines by the decimal point. And when you're finding the upper limit, you just add the least unit of measurements to the true value. Lower limit, it is the true value minus the least units of measurements. Absolute error is the least units of measurements divided by 2. If it's for 2 measurements, we subtract the recorded value minus the true value in the modulus bars, divide by the true value. Relative error is... So thank you for watching this video. Please watch these other videos which will be shown on the screen to watch my latest video and another recommended video. So I'll see you in the next video. Bye for now.